Initiative of India and working on, I believe, test development and teacher training. Sridhar.
Yeah. Good morning, thank you. Okay. So, why is it that as a society we are able to build better mobile phones, better buildings, better cars every few months, not few years, but we are not able to say that the education system we have today is better than what we went through as children? And this is the question that, I come from India, but I think we are addressing in a larger way. In our government schools, which kind of reflects what happens for education in the poor around the world, we have a situation of extremely low learning levels. The first part tells you that 50% of children are not able to write a sentence properly in grade 5. The second part says that only 25% of children in grade 4 are able to do grade 2 addition. In the private schools, which are schools for the rich, the problem that we have, again reflected in many other countries, is learning mechanically. Learning definitions happens well. Children can do an LCM problem quickly, but do not know what it means or where it is used. They can define density or explain something, but not understand what is happening. So what we do is that we try to ask deceptively simple questions, and I'm going to take these in some future slides also. Measurement, which of these is the largest angle, and use these to show that this gap exists in terms of how children are learning. One of the things we are able to do based on that is talk of benchmarking. The first slide shows about different cities in India. Is somebody doing better or not? The second one talks about different states and regions. And this evokes interest and gets discussion and starts people looking at not just how many schools I have and how many children are there, but are children really learning? Even more interestingly, it allows us to diagnose at the level of the question and the skill, saying how is the learning happening? What are the children doing compared to, for example, their international counterparts, which is the slide at the top. And this is interesting and controversial enough to have featured a cover in our Time magazine, the India Today. It also allows us to give insights to educators. What this graph basically shows is that 50% of children think that a plant taking in carbon dioxide is respiration, even though they learn this, and this does not change, the yellow line, from grade 4 to grade 9. So you are mechanically learning, but you are not necessarily understanding what you're doing. We then take this and talk to children and show teachers, this is what children say, and I hope the sound works here.
This is 1 centimeter.
Yeah.
And this to this?
That is 0 centimeter.
This is 0 centimeter.
This is 70% of grade 4 children, in terms of misconceptions that lead to this. Once we know these two things, how children are doing and why they are doing this, you basically develop information for teachers. We call these teacher sheets. We have this in a range of topics which tell teachers, why was this question asked, what did the children answer, what is going on in their mind, and how can we help them learn these things better. But these ideas, which are slightly theoretical and research-based, also have to be converted into something that children and teachers can actually use. So there are questions that provoke thinking that are used in schools, and programs with teachers to help them understand, these data, the research findings, and so on. It also helps us to analyze probably the most interesting thing, which is why do these misconceptions arise? In this example, why do children think, over 50%, that the largest angle is one whose arms are larger? And the answer seems to be that textbooks actually say that, an angle is formed when two lines meet at a point. And if you say that, you have to correct that by using methods where, for example, in this game, which is part of an adaptive learning tool that we use, where children learn angles by being told that here is a merry-go-round, and if you pay 360 rupees, you can go a full circle, and you can put different amounts and see how much you learn. And children actually do this. First they play it, and then this forms part of a larger learning tool, which actually has questions that check for understanding, which allow a child to automatically go to a remedial when they need it, work on real-life problems when they require that, and directs weaker children but allows stronger children choice. But we think that the real power of tools like this is going to come not from animation but from intelligence. And here is a very small example that shows in a very simple way that on the same problem, different children who make different mistakes are guided in different ways towards the right answer. And this is about the individualization and the personalization of education. And this is important because in a large country like India, we are talking of millions of children, and yet the question is that how can you provide a personalized education at scale? And we are doing this with rural areas also. These are the different types of personalization where you can actually choose what you are doing at a point of time if you know it. Does it work? So, based on a large number of students, pre-post controlled tests, what we basically find is that while all children benefit, it's the weakest children who benefit the most. And that is gratifying because it tells you that that is where personalized kind of inputs can help. And this is the only hope in a large educational system. Now, this is only partly about technology. Technology is the smaller piece. What we think it's really about is a new science called the science of learning. The whole focus of this science is how do people and children learn better. It's an interdisciplinary science, requiring education, computer science, artificial intelligence, and so on. It's a body of knowledge. It's a body of very systematic knowledge which says that when children are learning this is the body of misconceptions that exists. This is the way it is detected, and this is the way it can be corrected by taking children through different paths. And this kind of a body of knowledge, or the science of learning, is what will drive a lot of things in the future. And we believe that if we can do it, this classroom of the future will include a huge amount, about 50% of the time, children will actually be learning individually, engaging with systems. And 50% of the time, they will be with their peers, with an adult, doing things that we don't do in our schools today, whether it is feedbacking or social skills and so on. And many of the constructs that we take for granted in today's world, which is to have grade 4 and grade 8 and so on, and to progress through them, to have a standardized curriculum, to say that every child will be learning this at this point of time, we think will be very different in this world of the future if we can develop a science of learning and merge that with our education system. Thank you very much.
Thank you. I see the first use of green cards. Thank you.